Good morning. Today we're going to discuss about compiler design in that parsing and ambiguity. Myself Sharmila, assistant professor in Department of Computer Science Engineering in R.M.D Engineering College. In the last video, we have discussed about what are the different phases of compiler. In the first video, we have discussed what is the introduction to compiler. In this third video, we're going to discuss about the parsing and ambiguity. In which level is in the phase of compiler the parsing has done is in the parse generation, that is in the syntax analyzer phase. So we are first, before going into that, what are the different phases of compiler? The first one is lexical analyzer phase, lexical phase, syntax phase, semantic phase, intermediate code generator or code optimization, and code generation. These are different phases of compiler. This parsing is done and the parse tree is generated in the second phase of compiler, that is the syntax phase of compiler. In that introduction to parsing, we are just going to discuss what are the parsing techniques and what is parser, what is context free grammar, how it is derived, how the syntax directed translation is done. So what is language, what is automata? Before going into the parsing, we should know what is language and what is automata. And that language is nothing but a formal language, or very important the CS, especially in the programming language, it's a normal language. Regular language is the weakest formal language widely used in many applications. It's called as regular language. We're going to discuss what is a context free language here. The limitation of regular language is a finite automata that runs along long enough must repeat the state. Finite automata cannot remember the hash time number of time it has visited a particular state, but in the finite automata has a finite memory only enough to store in which state it is, cannot count except up to the finite limit. That is called as finite automata. The structure of compiler, just now we have discussed, the lexical analyzer token is given to passing is given to intermediate code generator, and the optimization is done. After optimization, code is generated, finally the machine code is arrived. Today we're going to start with where parsing. In that parsing, two things has done. One is input is sequence of token from lexical, and output is a syntax tree from the parser. Input is tokens. Tokens is nothing but each and every identifier symbols are separated and formed as a tokens. That token is given to the parser, and the parser will give the output as syntax tree of the program. For example, we have showed one example: id equal to id, id equal to int, and id equal to int. If else statement, we have done a parse tree for this statement. So you can understand, first identifier, if then else is a condition. If it is equal to, it will go to first. If it is equal to, it will go to second. If it is equal to integer, it will go to third. Like that, we have splitted a level. Why a tree? Each stage of compiler has two purposes. One is to detect and filter the out some class or error. Second one is to compute some new information or to translate the representation of program to make the things easier for the later stage. So these are the two things is involved in this compiler representation of the compiler has two purpose. Recursive structure of tree suits the recursive structure of language definition. With the tree latter stage, we can easily else case, like that we have seen one tree example using the else case. The comparison with lexicon analyzer, lexer input is sequence of character, output is sequence of token. Parser, that is parser input is sequence of token. What is the parser output? It's a parser output is a syntax tree. The role of parser: not all sequence of tokens are program. Parser must distinguish between valid and invalid sequence of tokens. We need a language for describing a valid sequence of token, a method for distinguish valid from invalid sequence of tokens. Programming language structure consider the arithmetic expression like plus, multiplication, parenthesis, or consider an arithmetic operation. Notations of programming: alternative notation, e tends to int, e tends to e plus e, like that we'll notate the fraction. The context free grammar is a set of non-terminal n, set of terminal t, start with the symbol s, and set of production. These are the four tuples: t, n, v, and s. Context free grammar, one example they have given: e tends to int, e tends to e plus e tends to e into e tends to open bracket e. By this convention, the first production starts with the one, that is the e character started, the first production of this context free grammar. We'll see one small example derivation for this e. We are giving a derivation: e tends to e plus e tends to, for the first e we are applying e into e, and then for this e we are applying int, for this e we are applying int, for this e we are applying int, finally int into int plus int. So the derivation is like this: e we are applying e plus e, again for this e we are applying e into e, for this e starting e we are int, and next e int, third e int. So here left right traversal is called as leftmost derivation, and from right we are traversing this, that is rightmost derivation. The stream of token is given to a parser. The parser, what is happening is, in translation rule, it will translate the syntax tree, that is a tokens, into a assembly code. The mechanism of syntax directed translation is, translation rule is defined for each production. Input is about string, build a parser, bottom up, topmost, why bottom up, non-terminal we are using, non-terminal node only after child transition. For that we are using a bottom up transition. Arithmetic expression, for the given expression they are writing a syntax directed translation rule. So for example one, I'll explain: e tends to e plus e, so e you consider e trans equal to e2 trans plus t trans. We are writing this expression as syntax directed translation rule. So for that, annotated parse tree is given 2 into 4 plus 5. For that we have given example. You can manually you can calculate. First 4 plus 5, what is the value? 9. So 2 plus 9, 2 into 9 is 18. So for that we are drawing a parse tree. So here e tends to t is 18, so we are converting t into f. So for that t we are applying f. For f is integer 2, for f9 open parenthesis, and 4 5, 4 plus 5 is 9, so 9 is calculated. 9 into 2 is 18, 18 is calculated and computed and stored in the value e. So here the leftmost derivation and rightmost derivation. See carefully, for this e they are applying e plus e. Again for the first e they are applying e into e. Again for the first e they are applying int. Next after that we are second e int, third e int. This is called from left to right, that is leftmost derivation. But see here, e tends to e into e, they are not applying for the first e. From this right side they are seeing the first one. From right side first one e they are applying int, then from the right side first one they are applying for e this int, from right side first one they are applying int. This is rightmost derivation, always acts as a rightmost non-terminal. This rightmost derivation means it will act on the last, that is a rightmost non-terminal value. But if it is a leftmost derivation, it will act from the leftmost terminal of the value from that derivation. So rightmost derivation, they have given an example. For this e they are applying int, again for this e they are applying e into e, for this e they are applying int, for this e they are applying int. For that we have completed a rightmost derivation parse tree. Derivation and parse tree, for each parse tree there is an exactly one leftmost and one rightmost derivation. The difference is the order in which the branches are added, not the structure of the tree. The ambiguity, what is ambiguity is, for the given example, for showing the same value a using the two different parts tree, we are getting the same value as we can derive, means that is ambiguous. The string x in L of G may have two or more parts tree. Witness x, the grammar G is said to be ambiguous if such case we exist, means that is called as ambiguous grammar. CFG tends to S comma A B C comma R comma S, where we are applying R tends to S B S C and S C S, two different production. We are getting the values A B A C A. So here also you see A B A C A, but here you are using the production is S B C. But here what we are using, S C S. Two different production, but the leaf node is A B A C A. So here the leaf node is A. So this type of grammar is ambiguous grammar. So finally what I am concluding is, today's video we have seen what is the parse tree. In which phase the parse tree is generated? It's in the second phase, that is called a syntax phase of the compiler. In that, given input is token, output is a parse tree. For that parse tree, we have discussed what is leftmost derivation, what is rightmost derivation, what is ambiguity. I hope you understand this session. You practice once the leftmost derivation and rightmost derivation.